Have you ever pondered over the possibility of time looping in on itself in the cosmos? Welcome to a journey through the fascinating concept of time loops and their potential existence within our vast cosmos. We often perceive time as a linear progression, a forward march from past to future. But what if it's not that simple? What if time, at least in some corners of the cosmos, is more of a loop circling back on itself? Imagine a cosmic dance where the end is also the beginning and the future might just be a reflection of the past. This isn't just a flight of fancy. In fact, it's a concept that some physicists are seriously exploring. The idea that time may not always be the one-directional arrow we think it is, but rather a swirling, looping path, is a tantalizing one. So let's dive deeper into this intriguing concept of cosmic time loops. To grasp the concept of time loops, we first need to understand what time is in physics. In the realm of physics, time is more than just ticks on a clock. It's a fundamental component of the universe, intertwined with space itself in the four-dimensional fabric known as space-time. This concept, introduced by Albert Einstein in his theory of relativity, revolutionized our understanding of the universe and our place within it. Time in physics is not an absolute concept. It's relative. It can stretch and compress depending on gravity and velocity, a phenomenon known as time dilation. When you're near a massive object or moving at near light speeds, time actually slows down. Yes, you heard it right. Your wristwatch would tick slower near a black hole or aboard a spaceship zooming at near light speed than it would here on Earth. Moreover, time isn't just a passive player in the universe. It has an active role in shaping the cosmos. It steers the course of everything, from the tiniest particles to the most gigantic galaxies. It's the invisible director guiding the cosmic dance of matter and energy. But time is also a bit of a mystery. While we can measure it with incredible precision, we still don't fully understand what it is. In the quantum realm, the microscopic world of particles, time seems to lose its forward-only arrow. Here, particles can move forward and backward in time, a baffling concept that challenges our everyday understanding of reality. And then there's the concept of the block universe, where past, present and future coexist. In this view, time is like a block of ice with every event, from the Big Bang to the end of the universe, frozen within it. We, as conscious beings, merely traverse this block, experiencing one slice of time at a time. These varied interpretations of time, from the relative to the quantum to the block universe, all contribute to our understanding of this enigmatic dimension. With this understanding of time, we can now explore the idea of time loops. So, what exactly are time loops? Let's dive right into it. Time loops, as the name suggests, propose a circular or cyclic nature of time, implying that events may repeat themselves over and over again. Imagine watching the same movie on repeat, but instead of hitting the replay button, the universe does it for you. Intriguing, isn't it? The theory of time loops presents a radical shift from our traditional linear understanding of time. We often perceive time as a straight line moving from the past through the present and into the future. However, time loops propose a different perspective. They suggest that time might be circular and that events could potentially recur indefinitely. So, what's the science behind it? The concept of time loops finds its roots in the field of theoretical physics. Some scientists propose that certain solutions to Einstein's equations of general relativity could allow for the existence of such time loops, or closed time-like curves. These are paths in space-time that, if traveled along, could lead someone back to their own past. But what does it mean for us and our understanding of the universe? The implications are profound. If time loops exist, they challenge our basic understanding of causality. The cause and effect relationship could become a complex web, with events influencing each other in a circular manner. So, time loops present an entirely new perspective on how we view time. Now, how do time loops fit into the context of the cosmos? To delve into this question, we must first remember that the universe is not only vast, but also incredibly complex. It's a cosmic ballet of stars and galaxies, constantly dancing to the tune of the laws of physics. But what if, within this grand spectacle, there exist phenomena that challenge our understanding of time and space? Imagine, if you will, a cosmic stage so vast that it allows for the existence of time loops. Theories from quantum physics and astrophysics provide us with some fascinating insights. Quantum physics, for instance, introduces us to the concept of quantum superposition, where particles can exist in multiple states simultaneously until observed. Expand this idea to the universe's scale, and one could speculate that time, too, might exist in multiple states, looping back on itself in ways we can't yet comprehend. Astrophysics, on the other hand, gives us the concept of wormholes, shortcuts through space-time that could, theoretically, allow for time travel. If such wormholes exist, and if they could be navigated, then we might have a framework for how time loops could occur. The universe's vastness and complexity might indeed allow for such phenomena. We're talking about a cosmos that contains billions of galaxies, each with billions of stars, each potentially hosting planets with their own unique laws of physics. With such a cosmic scale and diversity, it's not entirely outlandish to entertain the possibility of time loops. That said, it's important to remember that these are theories, speculative and intriguing, yes, but not yet proven. Science is a constantly evolving field, and our understanding of the universe continues to grow and change. As we probe deeper into the cosmos, who knows what we might uncover? So, in the grand scheme of the cosmos, time loops could be a fascinating reality. But are there any indications of time loops actually existing? Well, let's delve into some intriguing observations and experiments that might just hint at the existence of time loops. In the realm of quantum physics, scientists have been able to create a simulated time loop. They did this using particles of light known as photons to simulate quantum particles traveling through time. In the larger astronomical scale, there are phenomena that seem to defy our understanding of time. For instance, the existence of cosmic strings, hypothetical one-dimensional defects in the fabric of the universe, could potentially create loops in time due to their immense gravitational pull. Moreover, certain solutions to Einstein's field equations in general relativity allow for the possibility of time loops, known as closed time-like curves. These are routes through space-time that, if traveled, could bring one back to one's own past. While the evidence is not conclusive, it certainly adds weight to the theory of time loops. If time loops do exist, what does this mean for us and our understanding of the universe? Well, time loops would challenge our fundamental perception of time as a linear one-way street. Instead, imagine a roundabout where time circles back on itself, repeating events in a never-ending cycle. This could fundamentally alter how we perceive life and existence. We'd have to reconsider our notions of cause and effect. If time can loop, then an effect could potentially precede its cause, turning our understanding of causality on its head. This paradoxical nature of time loops could provide fresh insights into the mysteries of quantum mechanics, a field already known for its counterintuitive phenomena. Our interpretation of physics would demand a radical shift. The laws of physics as we know them are based on time's unidirectional flow. If time loops exist, we might need new laws, or at the very least a significant reinterpretation of current ones. The existence of time loops could also have philosophical implications. If time is cyclical, how does that affect our understanding of free will? Are we merely actors following a preordained script, destined to repeat our actions in an infinite loop? The very concept raises profound questions about destiny, fate, and the nature of reality itself. So time loops could potentially revolutionize our understanding of the universe. This is not just about science, but about the fundamental questions of existence, reality, and our place in the cosmos. So, are there time loops in the cosmos? This is the question we've been exploring throughout our journey. We've delved into the intricacies of time as understood in physics, pondered on the theory of time loops, and examined their potential existence in the cosmos. We've seen that, while there's no definitive evidence of time loops, there are intriguing indications that suggest their possibility. Theoretical models have proposed their existence, and some cosmological phenomena seem to hint at their presence. Yet the jury is still out on this captivating concept. The implications of time loops are profound, reshaping our understanding of reality and our place within it. They challenge our perceptions of linearity and causality, introducing a universe where time might curve back on itself. While we may not have a definite answer, the concept of time loops continues to captivate scientists and laymen alike, reminding us of the vast mysteries the cosmos holds. The quest for understanding continues, and with it our fascination with the enigma of time.